So, hi everyone. Today in this topic, we are going to talk about enzyme inhibition. Okay, so the question here is what is enzyme inhibition and what are their types? So here, an enzyme inhibitor is a molecule that disrupts the normal reaction pathway between an enzyme and a substrate. Silbi, para siyang may kumakabit. An enzyme inhibitor is a molecule that binds to an enzyme and blocks its activity. Kung sa gugma pa, naay duha ka tawo na naghigugma ay, pero naay usa ka tawo ni eksena sa ilang kinabuhi o giguba ang ilang paghigugma. Char. Okay, moving on. There are three types of inhibition reactions. The first one is the competitive inhibition. The second is the non-competitive inhibition. And the third one is the uncompetitive inhibition. So this is how they look like. These are inhibitors inside on top of the enzyme. But before that, I'm going to show first how does a normal enzyme reaction happens. So here, in a normal reaction, a substrate binds to an enzyme via the active site to form an enzyme substrate complex. And the shape and properties of the substrate and active site are complementary, which means they are meant for each other and resulting in enzyme substrate specificity or enzyme substrate complex. When binding occurs, the active site undergoes a conformational change to optimally interact with the substrate in an induced fate. As you can see, perfect fit kays lang duha, which means they are meant for each other. So this conformational change destabilizes chemical bonds within the substrate, lowering the activation energy. And as a consequence of enzyme interaction, the substrate is converted into product at an accelerated rate. I'm going to show you an illustration or drawing on how does this work. So this is how a normal enzyme reaction looks like. Here we have our enzyme, our substrate, and then our double arrow, so enzyme substrate complex and enzyme and turns into a product. So what happens here is that in a normal reaction, so a substrate binds to an enzyme, so this substrate binds to an enzyme via the active site. So this is the area, is the active site of the enzyme to form an enzyme substrate complex. So this is how it is going to happen for the normal enzyme reaction. So the shape and properties of the substrate and active site are complementary. So in the one that I showed you in our PowerPoint, you can totally see that they are meant for each other. So it states here that the properties of the substrate and active site are complementary, resulting in enzyme substrate specificity. So when the binding occurs, the active site undergoes a conformational change to optimally interact with the substrate, so induce fit. In our PowerPoint, you can totally see that the substrate is totally fitted to the enzyme. So in here, in the enzyme substrate complex. So again, this conformational change destabilize chemical bonds within the substrate, lowering the activational energy. So here, go to move forward, the enzyme and the byproduct. Moving forward, let's talk about the first inhibition, which is the competitive inhibition. So, competitive inhibition involves a molecule other than a substrate binding to the enzyme's active site. This molecule is what we call inhibitor. So the molecule inhibitor is structurally and chemically similar to the substrate. That is why it is able to bind to the active site. And the competitive inhibitor blocks the active site and thus prevent substrate binding. So as the inhibitor is in competition with substrate, so nag-compete na sang duha, the effect of this can reduce by increasing substrate concentration. That is why it is increasing Km and normal Vmax. So Km is a kinetic parameter which gives the substrate concentration at which half of the maximum enzymatic reaction rate is attained. So Km is determined not only by substrate binding affinity but also by how quickly the enzyme substrate complex is turned over into product. Meanwhile, in Vmax, it is the reaction rate when the enzyme is fully saturated by substrate. So it indicates that all the binding sites are being constantly reoccupied. So this is the drawing or like the illustration of how this reaction happens. So here we have the competitive inhibitor. So your green, this represents enzyme, and the red one is the substrate, and this goes to double arrow. Here, the green one is the enzyme, and the red is the substrate. This whole thing together is called enzyme substrate complex, and this yields to this one, green enzyme, and the blue one is the product. So I draw here a black. This represents an inhibitor. So the competitive inhibitor is structurally similar to the normal substrate. So you can see there in this red one. And the structure looks almost exactly similar. What happens to this reaction is, as the substrate reacts to the enzyme here, as the substrate tries to react to the enzyme, the inhibitor will come in here, in this active site of the enzyme, and bind it into the active site of the enzyme. So can the substrate get in there if the inhibitor is bound? So if the inhibitor is here, well then the answer is no. Since the inhibitor bounds or binds with the enzyme, this is what it will look like. The inhibitor bind to the active site here of the enzyme, fitting inside to that pocket. So now siya sa inside. So now what will happen? The substrate, this one, can't bind. They will not turn into an enzyme substrate complex. So because the substrate cannot bind into the active site, the enzyme's affinity into the substrate goes down, and the affinity of the inhibitor goes up. Now the only way for this reaction to continue to proceed is if we do something. And what is that? If we increase the substrate concentration enough, if we increase this towards the affinity that the enzyme has for the inhibitor, might go down a little bit. So this can make the substrate compete and oust the inhibitor to that active site. Then what can happen? Then we can form more enzyme substrate. So we can go back to here, enzyme substrate complex, and which dissociates to enzyme products. That enzyme product. So that is the competitive inhibitor. Moving forward to the non-competitive inhibition, from the word non-competitive, so ayaw mo niyang makipaglaban. So in non-competitive inhibition, this involves a molecule binding to a site other than the active site. So the active site is this one in the center ng kanang permi doolon sa substrate. So it involves a molecule binding to a site other than the active site or an allosteric site. So the binding of the inhibitor to the allosteric site causes a conformational change to the enzyme's active site. This results of this change. The active site and substrate no longer share specificity, meaning the substrate cannot bind. So, gipulihan na siya. So, as the inhibitor is not in direct competition with the substrate, increasing substrate levels cannot mitigate the inhibitor's effect. So, the Km is normal or unchanged while the Vmax is decreasing. So, this is the illustration I'm going to show you to the non-competitive inhibition. So, in this inhibition, what happens is that, let me show you. What happens here is that the inhibitor does not bind on the active site here, kaning center sa enzyme. Rather, they will create a pocket here. There's a little pocket here in the enzyme that is kind of always open. There's a little pocket here on the enzyme that is kind of always open. And what happened is that this inhibitor comes and binds here. So what happens here is there is a little pocket here on the enzyme that is kind of always open. And what happened is that this inhibitor comes here, so dire, and then he will create a bind. Comes here and binds on the other side of the enzyme. And that is not the active site. Remember, the active site is here in the center of the enzyme. But this area is called the allosteric site. Again, allosteric site. So this area is called the allosteric site. And what happens when the inhibitor comes in and binds in that free enzyme? So what do we get out of this? So this inhibitor bounds on the enzyme, but this enzyme can still react to the substrate. So again, what do we get out of this? This inhibitor bounds on the enzyme, but still the enzyme can still react to the substrate. So the substrate can still bind to the enzyme. So this is what happens. So the substrate is bound to the active site. So this is the area of the active site of the enzyme, while the inhibitor binds to the allosteric site. So this is the area of allosteric site. So here we have an enzyme substrate inhibitor complex. Forgot to put complex. So can this product, or can this be produced into a product? The answer is no. This reaction can never produce a product. That is why there is no product formed from this reaction. So moving forward to the third, it is the uncompetitive inhibition. So in this inhibition, it binds only to the substrate enzyme complex in uncompetitive inhibition. So the reactions involving two or more substrates or products, the uncompetitive inhibition is common. So non-competitive inhibition can occur with or without the presence of the substrate, whereas uncompetitive inhibition, this requires the formation of an enzyme substrate complex. So na-form na siya daan into an enzyme substrate complex o sa siya mo apil-apil sa kanina enzyme o sa siya mo inhibit the torrent. In here, the Km or the kinetic parameter is decreasing while the Vmax is decreasing. So I'm going to show you a drawing illustration on how this inhibition process happens. Okay, so now let's move on to the uncompetitive inhibitor. For this one, the difference here is that the inhibitor, so this is the inhibitor, only binds to the enzyme complex substrate. Silbi ni shortcut siya. So he will bind here in the enzyme substrate complex. So the inhibitor makes out towards the, it's called allosteric site. So ano siya dira magtambay, kakabit siya dito, mga bit. Now, we have the uncompetitive inhibitor. So this is why it's called uncompetitive inhibitor, kay mang shortcut man siya. So di siya moagi di aring dapita, kay lagi guna siya mo shortcut. Next is, if the uncompetitive inhibitor binds on this, the enzyme will have a hard time turning, or the product formation is gonna be decreasing. So, onti lang yung mapuproduce netong enzyme na to. So, can we form a product from this? The answer is no. We cannot form a product from this. Dapat red para intense. No. We cannot form a product from this. We get no product. This is enzyme substrate inhibitor complex. Again, I'm going to type it. Wait lang. So, again, this enzyme is enzyme substrate inhibitor. Now, this is now an enzyme substrate inhibitor complex. So, but if by some way we are able to release the inhibitor, so tanggalin natin yung inhibitor from the allosteric site, we can form or get enzyme substrate which can progress forming into a product. Yes, that's all for uncompetitive inhibitor. So now we're done talking about the three inhibition. Let's see some examples of enzyme inhibition. So the first one is a summary or recap. Enzyme inhibitors can serve a variety of purpose, including in medicine, to treat disease and agriculture as pesticides. So an example of a use for competitive inhibitor is in the treatment of influenza via the neuraminidase. An example of a use for a competitive inhibitor is in the treatment of influenza via the neuraminidase inhibitor or the Relenza. An example of a use for a non-competitive inhibitor is in the use of cyanide as a poison to prevent aerobic respiration. Mostly cyanide. Cyanide is a poison. And an example of a use for a non-competitive inhibitor is in the use of cyanide as a poison. This is what happens. It prevents aerobic respiration, so it stops you from breathing once you inhale or eat this type of poison. So an example to uncompetitive inhibition are drugs to treat cases of poisoning by methanol or ethylene glycol that act as uncompetitive inhibitor. Now let's move on to the next topic for this unit. Thank you.